Hi, welcome to a complete course in calculus. This is Tadressa. So this will be my last review, which is on how to graph a function. So this question will have a lot of, parts. So I'm gonna show you one by one. So the function is f of x equal to x over x squared plus 4. So the first part says find the domain, okay? So as you can see here, this is rational function whose denominator is x squared plus 4. So x squared plus 4 will never be 0. X squared plus 4 is the sum of two positive numbers. It will never be 0. So the domain will be negative infinity to infinity. Now I want to find what is the x-intercept and the y-intercept. So for x-intercept, you know that I have to set y equal to 0, right? So if y equal to 0, so 0 equal to x over x squared plus 4. For a fraction to be 0, the numerator must be 0, right? So x equal to 0, that's what I have now. So x is 0, y is 0. For y-intercept, x must be 0. So if x is 0, this guy is 0, 0 plus 4 is 4, 0 over 4, which is 0. So the x and the y-intercept is the origin. So part C, I want to find what is called the vertical asymptote. So for vertical asymptote, the candidates are, the zeros of the denominator, but you can see that x squared plus 4 will never be equal to 0. So there's no number that makes the limit of f of x as x approach to a number either from the right or from the left goes to plus or minus infinity. So this is the definition of a vertical asymptote. So in this case, we don't have any number, so no vertical asymptote. So for horizontal asymptote, I have to find what is the limit of x over x squared plus 4 as x approaches to either infinity or negative infinity. So limit at infinity. So this is the end behavior. So what you need to do is you need to divide both the numerator and the denominator by the term with the highest exponent, in this case x squared. So that would give me limit of x over x squared divided by x squared over x squared plus 4 over x squared. So I'm dividing both the numerator and the denominator by x squared. X goes to either infinity or minus infinity. So this is limit of x over x squared is 1 over x divided by 1 plus 4 over x squared. So x approaches to plus or minus infinity. So as x approaches to infinity or minus infinity, this guy goes to 0. This guy goes to 0. I have 1 plus 0 is 0, so it will be 0 over 1, which is equal to 0. So what does that mean? Y equal to 0 is the horizontal asymptote. All right, so the next step is I want to find the derivative. So because for finding the interval where f is increasing, decreasing, critical number, relative max, relative min, I need to find the derivative. So let's find the derivative using quotient rule. What is the derivative of x? 1 times x squared plus 4 minus x times the derivative of x squared plus 4 is what? 2x divided by x squared plus 4 squared. Okay? Now, when you simplify this guy, this should leave you with minus x squared plus 4 divided by x squared plus 4 squared. So I can factor out the minus if you want, and then it will be minus of x squared minus 4 divided by x squared plus 4 squared, which is minus of x plus 2 times x minus. That's the difference of two squares, which is x squared plus 4 squared. That will be what the derivative. Now the next part is I want to find what is called CN, critical number. So critical number means what? It's a number in the domain where the derivative is 0 or does not exist. So when will this derivative be equal to 0? If this guy is equal to 0, right? And this guy will equal to 0 if the numerator is 0. If the numerator is 0 means what? X plus 2 must be 0 or x minus 2 must be 0. So x equal to what? Negative 2 or 2. So x equal to plus or minus 2. The second one is f prime at x does not exist. Does not exist. As you can see, the denominator will never be equal to 0. So there is no value of x where the derivative will be undefined or does not exist. So the only critical number will be what? X equal to plus or minus 2. Now let's find the interval where f is increasing and decreasing. In that case, we have now everything I need to determine the sign of f prime, sign chart, okay? So I have -2, I have 2, so I'm testing f prime, okay, keep in mind. So if I pick a number to the left of -2, let's say -3, -3 plus 2 is negative, -3 minus 2 is negative, right? Negative times negative is positive. I have a minus sign. No matter what, the denominator is always positive. So this guy will be minus sign. So if you pick a number between -2 and 2, so the answer will be, let's say you pick, -1. So if you pick -1 plus 2 is positive, -1 minus 2 is negative. So positive, negative is negative. With the minus, it will be positive. And then here, if you pick 3 plus 2 is positive, 3 minus 2 is positive, but I have a minus sign here, it will be minus. So from this chart, it will be increasing from -infinity to 2. Increasing means the first derivative greater than 0. And it's decreasing from -infinity to -2 union 2 to infinity. As you can see here, at x equal to -2, it will be decreasing, then increasing. So this is relative minimum. So we have relative minimum at -2, and the value is f at -2. So the relative minimum will be -2. So if you evaluate that, we should give you -1/4. And then relative max, as you can see here at 2, it's increasing, then decreasing. So this is relative max, okay? So it's at 2, f of 2. So if you evaluate it again, it will be 1/4. So we have the interval where it's increasing, decreasing, relative max, relative min. Now, the last part is concavity. So for concavity, we need to find the second derivative. So let's find the second derivative. So what is the derivative of -x squared plus 4? It's -2x times x squared plus 4 square minus -x squared plus 4 times the derivative of x squared plus 4 square, which is 2 times x squared plus 4 times the derivative of the inside 2x, everything divided by what? X squared plus 4 square, which will be to the power of 4. Now again, I mean, what you need to do is just simplify one of them here and then FOIL simplify. So you should come up with 2x times x squared minus 12 divided by x squared plus 4 cube. Okay, so that should be the second derivative. Now, the second derivative will be 0 because I have to find the partition number. So the second derivative will be 0, means this 2x must be 0 or x squared minus 12 must be 0. So this means x equals 0 or x equal to radical plus or minus radical 12. So 12 means 4 times 3. Radical 4 is 2, so it will be 2√3. So as you can see, the first derivative exists at 0 at this number. So these 3 numbers will be inflection points. So I'll come back to that. So the next part is the concavity. So for concavity, we do sign chart for the second derivative. So I have -2√3, 0, and 2√3. So if you test the second derivative at these points, so this is what the sign is going to look like, okay? It's straightforward. You just need to plug numbers, okay? So what that means? From here, concave up. Concave up means the second derivative must be greater than 0, which is -2√3, 0, union 2√3, 0, 0 to infinity. And concave down means negative, which is -infinity to -2√3, union 0 to 2√3. So these are the intervals where it will be concave. It will be concave up and down. Okay. So the next part is inflection point. So inflection point, again, as I said, it should be a point where, you know, concavity changes and there is a tangent line. There is a tangent line means the derivative exists or it has a vertical tangent line. That is what the definition of inflection point is. So on our case, I have 0, f of 0, which is 0, 0. And then the next point is 2 root 3, f of 2 root 3, which is 2 root 3, comma, at 2 root 3, it is root 3 over 8. And the third one is minus 2 root 3, f of minus 2 root 3, which is minus 2 root 3, comma, at the negative, it will be minus root 3 over 8. So these are the inflection points. Now, if you use all that information, whatever we have to graph it, this is what the roughly the graph looks like. So okay, so that is what it looks like. So this is negative 2, negative 1 over 4. This is 2, 1 over 4. This is the x and the y intercept, which is 0, 0. And then this is where it changes concavity, which is minus 2 root 3, comma, minus root 3 over 8. And this is another place where it changes concavity, which is 2 root 3, root 3 over 8. That's all. Thank you very much. I'll see you in the next video.